ever wonder why fireworks are different colors?
But we always need oxygen to burn, well, anything. All right, guys, take care.
Miss Neutrina,
Why does fire look so orangey? Well, fire doesn't always have to be orange. I mean, think about it. Have you ever seen fire that's a different color?
my home still has blue fire.
That's right. Certain chemical compounds can burn all colors of the rainbow.
What? Are they different temperatures too? Can we see some?
Well,
Show the kids something cool for once.
so don't show you.
Well, if you won't make colored fire, I will.
You burn your eye out! If we're gonna do color fire, we're gonna do it right. What changes the color of fire? And does this change in color mean a change in temperature? Since we can test this out, we have testable questions, which means we got ourselves an experiment. Oh yeah, safety first.
And I'm more like safety third.
Unless you're on a fume hood like this, you know, one that pulls all the fumes from an experiment out of the building, do not try this at home.
We'll start with plain old everyday salt, aka sodium chloride. As the salt burns, it gives off a yellow flame that measures at around 1,000 degrees Celsius or 1,830 degrees Fahrenheit or 1,270 kelvins. We now move on to lithium chloride. As it burns, it emits a red flame that measures at around 800 degrees Celsius or 1,470 degrees Fahrenheit. Side discovery. The next day, lithium chloride that was left out changed into a liquid. Turns out that lithium chloride is so absorbent of water that it forms a self-solution when exposed to air. The more humid, the more liquid will appear. Next up is sodium borate, aka borax.
Hi, it's me, Borax.
No, borax.
Not very nice.
Borax is supposed to turn a light green. Not satisfied, we added copper sulfate, which gave off more green, but the green parts of a flame don't equate to a certain temperature. Magnesium sulfate gave us a hot bluish white, but even hotter is straight up magnesium. And when it burns, it flashes a brilliant, cool white. Magnesium burns at around 2,200 degrees Celsius. That's a whopping 4,000 degrees Fahrenheit. It was so hot, it burned a hole through the aluminum. As we can see here, what makes up the compound determines its color, or should we say, temperature. This is basically how fireworks get their colors. Different chemical compounds burning at different temperatures.
Unlike in art with blue being a cold color and red being a warm color, blue is the hottest you can get with fire and stars, while red is the coolest.
Ugh, what stinks? Smells like barbecue dog hair.
I'm okay.
How? You burnt your eye out.
I still got one. Worth it.
This is why we say safety first. Thanks for watching. If you like this, like it. If you have a question or comment, drop it below. Until next time, Brainiacs, Miss Neutrina out.
John is too busy.
Borat, yeah, it's me, Borat. Oh, not very nice.
Gonna cut? I don't know. Any direction?